test on that.
Ready for test.
Test, test.
Test, test.
Well, good morning, everyone. We'll go ahead and kind of get things kicked off and started. I'm Tyler Williams. I'm the extension educator located here in Lancaster County. I also serve Odo and Cass County, so you've probably seen me around. I see a number of familiar faces, so thanks for coming back. And last year when we started this, January 4th, it was -2 degrees. So today is like 24, 25. So as your local meteorologist, you're welcome. I was at a talk yesterday and I got one thank you for the weather, but I get blamed all the time. So anyway, so my background's in meteorology and agronomy, so I do kind of that type of work. So for today, a couple housekeeping things before we really get started. We're live streaming this year, so there are about 20 so people that signed up to live stream. So you'll kind of see a camera in the back, and they can see in the screen and Justin, but they can't really see you guys. So you're in luck. So unless you come up and do this, they won't know you're here. So anyway, also restrooms. You notice that our restrooms over there are getting remodeled right now. So the restrooms are currently back down this hallway. You can sneak out that door if you'd like, or you can go right out there and cut through the room next door. They're just down the hall about 3 doors down if you need to use the restroom. Trying to think what else. Oh, if you are here to get CCA credits, I'll pass around a sheet here in a minute, and you can sign up for those. I didn't find a good spot to set them up. I think that's it. Our sponsor today is SARE. So Gary Leswing's our Nebraska representative to SARE, which is Sustainable Ag Research and Education. So we thank them for our sponsors. And we also have a number of other sponsors for the rest of the series. You can see those on the front of your books. But so yeah, big thanks to our sponsors. They allow us to bring in pretty good food and put this live stream. And so we thank them and allow this to happen. So I think that is all that I have. So again, this is if you've been here before, you know it's a pretty informal discussion. We like to ask questions and talk kind of whenever you get a question. I know the speakers don't mind if they get interrupted. It's kind of how we do things here. When Justin is done, we'll have a general discussion. So I know a lot of people like to learn from each other. You can learn from us. You can learn from your seed dealers. You can also learn a lot from each other. So I like to have a general discussion, ask questions, answer questions of each other. And we got a number of people in the room that can help with that as well. So we'll kind of take that discussion time, have a break, use restrooms, grab some more food because there's always lots of food that needs eaten. And then Paul will come up after that. So it's kind of the layout of the day. Hopefully you all got your materials and agendas at the front door. And if you didn't, I'll print some more. So with that, we'll go ahead and get started. Again, first up is Justin McMechan. He's a cropping system specialist, entomologist, doctor of plant health. He's got the whole alphabet after his name. So he's done a lot of work with cover crops and insects. It's kind of a new thing as you get into this next level of cover cropping. Some of the problems that you don't maybe anticipate or might not be as easy to solve. So glad to have him here today and share with us all of his knowledge. So I'll go ahead and turn it over to Justin.
Well, thanks, Tyler. And thanks for the introduction. You guys hear me okay? Is that coming through? Yep. All right. So yeah, the topic today, and for those of you that were at the Corn Expo yesterday, there's no excuses for not getting all this because this is the second time. But I'll probably remember more today than yesterday. So cover crops and insects, finding a balance between risk and benefits. How many of you think of insects when you're planting your cover crop? No hands, no surprise. Yeah, a few. Oh, good. It's a rare thing. Usually I get a phone call when we have a problem. And so I don't want to just talk about problems today. I want to talk about the benefits that come from this too. Because often what happens is we perceive the risk, we focus on the risk, and then we get sometimes to the preventative type strategies where we're applying insecticides, say at termination. And I want to warn you on the potential losses and benefits that you can see if you move to those types of practices. So it's a little bit complicated in the system. It's even more complicated year to year. But there is certainly opportunity to do this through scouting and other efforts to make sure that you get the most out of the process. So we're going to flip this system back and forth. This is the corn soybean rotation, but we're going to do in reverse, starting with corn, planting cover crops, and going to soybeans. And so you're going to see a combination of all of those. And certainly, when you look at the system, if you're going to look at a potential risk scenario for insects, when you're going from a grass to a grass, that's when you kind of amplify that potential. But the same thing could be said for beneficial insects in the same set. So NRCS, if you focus within Nebraska here, this is the map of the U.S., of course, and within Nebraska, there are 2 different zones. Zone 2 is 15 days prior to plant. This is all dry land systems, so non-irrigated systems. And this is primarily done for the sake of water and not for any insect-related scenarios or conditions. The other zone is the terminate at or before planting. Basically, NRCS doesn't want you to have your cash crop emerging and have not terminated your cover crop. They want those if there's more than 5 days delay, then you can run into some issues. They've got these guidelines. They've got a code 340 here in Nebraska that has all the guidelines on it, but they're looking for about 6 to 8 inches of extended leaf height growth. The reason they're looking for that is where erosion and the benefits of cover crops can be noticed. And then, they prefer up to 10 to 12 inches. But that's kind of some of the guidelines we use when we're conducting our studies, is fitting into those NRCS guidelines and say, okay, we need to match this. When do we meet those types of conditions with different, planting dates and other strategies? So we all know the benefits of why we'd use cover crops: reduce soil erosion, this increased weed competition. This is where I really got into this system. I'm not a weed scientist, but the weed scientists were looking at these immediate potential benefits from cover crops, for reducing weed seed or weed competition. And so this is really where we run into kind of this nexus of crossing between insects in the system and the need to control weeds potentially with the biomass that can be present, and then increase soil organic matter and limit nitrate leaching. So all of this depends, just like I just mentioned, on the maximizing biomass prior to termination. Absence of water or anything else, that's the goal. And so often it's this pressure window between getting enough biomass in the spring to still plant your cash crop and maximize the benefits of your cash crop. So it's a systems approach, right? Trying to lift everything up and make sure you get the most out of it. So I like to do this to the weed scientists. I think this chart generally, or this graph generally, annoys them because it says things are very clear, which Chris continually reminds me they are not clear in terms of the response. But typically this is what we expect. Weed control goes up. The longer you hold the cover crop in the system, the more biomass accumulates in that system, the more competition you have with other weeds that are in the system. And it makes sense, right? It's just not that direct of a relationship. And varies a little bit. For insects, I like to give a lot of flexibility to the system. This allows me to get out of things if I'm too clear on the response. So these shaded margins here are the relative variability of this system year to year as kind of a general understanding. So we can have absolutely no risk of pest pressure, which this was this past year. Did anybody have trouble with insects and cover crops this past year? No. It was a very quiet year. I did a ton of studies. As an entomologist, I like to find those because it helps me understand and then better, direct you if there's going to be an issue. But it was completely silent this year, 1% to 2% pressure in a lot of the fields we were in. And then, back to 2017, when we had weed stem maggot, which I'll talk about at the end of the presentation, that ramped up for some growers. So it varied, across Nebraska, but there was growers experiencing significant pest pressure. And so how do we narrow those margins, right? How do we narrow that down so we're not dealing with so much variability from an insect standpoint and get a better handle? And then I could cross through risk of pests, put beneficial insects up there in the same response, right? We could have a massive amount of beneficial insect presence in these fields, which would be great for all the ecosystem services they bring with them, and they bring quite a bit. Or we could see very little. And both of these potential scenarios could be influenced by your management practices that you're using in the field, maybe the cover crop species that you're using, that termination date, which I think is a critical component for a lot of insects to carry over. Insects are just like us, looking for a food source, right? Or they're looking for a habitat. And so a cover crop is a potential habitat. It's just what insect is in that habitat. So any questions on this so far? This is kind of the 10,000 foot view of cover crops from an entomology standpoint. Okay, so lots of studies have been done, and it should give you some confidence. The unfortunate part is they're good studies. They're just not directed at our systems. Some of these are older papers, and you'd say, well, 1989 isn't that old, but it is in terms of what we've been doing with cover crops. Our termination methods have changed. We're using a lot of different techniques. And so even some of these newer papers, they're not really focused on the management practices. They're evaluating a static system. So they're saying, oh, we terminate 2 weeks prior to planting. This is what we see. They're not looking at 2 weeks prior and at plant as a comparison. And so that makes it difficult to say, well, how could the strategies that you use influence the abundance of insects in a system, pest or beneficial? And so that's why we really started digging into this. But lots of these are generalist predators. They're ground beetles. They're lady beetles. They're minute pirate bugs. Very generalist things in the system that feed on a lot of potential pests that we could see in the system. So this is the good side. And then a relatively unforeseen part, or what people don't often think of, is the seed feeders. So these are not insects that are feeding on other insects, but they're actually feeding on weed seeds in the field, which when you're trying to manage resistant weeds and other things, these are out there consuming what seeds are present on the soil surface. And Dunbar found significant activity of seed feeders in cover crop systems. And so This is the part I want to remind you of, because often we just say, oh, pests, and I can tank mix and clear this up. Well, you'd be impacting a lot of these things potentially in that system. Unfortunately, there's probably the same amount of a list for pests in the system. You notice Dunbar in both cases, 1 year after the other. He was evaluating each one of the systems. But really the increased risk of pests is really based on their ecology. Do we expect them to be in the system? What do we expect to show up based on what we know their behavior is like? And so yes, there are this list of publications, as well as the one we're currently publishing on wheat stem maggot. So we're going to start off with the beneficials and remind you that there are some key pests out there that do get controlled by these systems. This is from South Dakota, Lundgren and Fergen from 2010. How many plant slender wheatgrass as a cover crop? Not many, right? We're planting wheat or rye, triticale, some other legumes. So fall planted slender wheatgrass, not a common part of our system. So the question is, what would this mean in terms of using other cereal cover crops? But planted in early September in South Dakota, terminated at corn planting. So this is that 0-day termination. And then the nice part about this one is we reduced the abundance of western corn rootworm at third instar larvae during both years of the study. That's pretty promising. So as they develop through their system, they're feeding on the roots. And so the decline in the population here was not significant in first or second, but the decline here with the cover crop being present is a really helpful potential on this system to reduce their activity in the system. And they looked at an increase in predator abundance. That's this graph here. So you can see the cover crops, there's a bump up in the abundance of predators. These were hand collected. And there was a strong relationship between the predator abundance and the reduction in third instar larvae. So that lineup in time was well equated. And so this is good news. Even better news is that this translates to less damage on a corn crop, right? That's the real measure of what you'll be taking away. It's nice if they're reduced, but does it make sense in terms of potential yield savings? This is not a direct yield relationship, but if you go on the high side of this chart, the higher, the taller this bar is, the more damage that's out there. Okay, and the more damage would likely translate to potential yield loss. And so the bare soils where there is no cover crop relative to the cover crop, this being less than 0.05 means it's significant. We're seeing a significant reduction in root damage as a result of this potential system, and even more significant in 2008. So these are good signs that cover crops play a role in what is a $1 billion pest in the Midwest, the western corn rootworm. So here's another one, ground beetles. Rye cover crop from soybeans to soybeans and corn. The impact was only observed in those that were planted to soybeans. So now the subsequent crop influenced the relationship in this particular study. And what you're going to see is a lot of variability between studies. And I'm going to show you a study that was done here in Nebraska, funded by the Nebraska Soybean Board. And you can see even between the sites in Nebraska how much variability we see. And so I'm going to give you an understanding of the variability that you might expect. And hopefully through the process of doing all these studies, we'll start to capture some of those relationships so we can better understand that. But a greater abundance of ground beetles, most frequently captured in June and July, which is a little bit past when the cover crops are out of these systems. But a diverse group of beetles, as well as some seed feeders and predators. And this was terminated 2 weeks prior to planting a cash crop. So again, they're not evaluating the termination dates, but you are seeing some different termination dates in these studies. Here's one more, and this one's pretty interesting. I bring this up because I think it's important to note this when you're standing in a field and trying to understand what's going on. Insects, unlike weeds and other things, during the course of the season, they move a lot. And so it makes studying them kind of difficult. But here's the system again. They had a range of crops that they came out of: corn, wheat, and oats. This was done in Minnesota by Bob Koch. The rye was planted in late September through early October. They mowed it. So how many of you mow your cover crops out? Not many, right? We terminate with Roundup, glyphosate, use chemicals. So the question is, does that influence the method of termination, influence this relationship? But obviously soybean aphid is a big focus up there, and you can see that with rye, with the cover crop, a significant reduction in the number of aphids per plant in this system, and that is a significant number. So you get all excited, and I was all excited reading this paper, and I leaned over here and went, that makes no sense. What we have is a reduction in, there's reduced amount of predators in that rye cover crop as well. So what's going on? Well, they move. So they were probably in this system early on, keeping the population relatively low. And as the population of aphids jumped up, they followed them into those no cover treatments or plots. And so they moved into there, and now they're consuming them. So even in this case, it's really hard for us to temporally understand how long that relationship exists because they move so quickly to where their prey is. And this is just a sampling of what was found. So syrphid flies, you see these in the field, they're usually hovering around you. These are great predators as immatures. We've got minute pirate bugs. These are the ones that'll annoy you in your backyard in the fall. They're usually in corn and soybeans in pretty high populations. They're a pretty voracious predator. And then lady beetles as well. These were some of the most common things that they found in that particular system. So we're going to focus in here on Nebraska. This is 1 year of this study. We're doing this for another 3 years. But what we had was a cover crop planted to wheat or rye. It was planted in November, so this is a little bit later of a planting. You remember the NRCS guidelines, if you're on an EQIP program within 2 weeks of planting, they'd like that to go in. So it's a little bit shorter of a window. But we were a little bit later than that getting these in. And then we had 2 termination dates in the spring with soybeans being planted on the last termination date. So essentially 2 weeks prior and at planting for soybeans for the terminations. We did this at 4 different locations in Nebraska as part of the soybean management field days. We took the biomass at termination, pounds per acre, and then we took extended leaf height as a way of saying, did we meet NRCS guidelines or not? And we planted a little bit late. So we were, I think, late May through early June plantings on this. And so that also changes the insect dynamics in the system. Those of you that are familiar with bean leaf beetle, that's a very early season pest. So planting later takes the pressure off of bean leaf beetle. So the insects, we focused on a damage assessment, incidence, number of plants, and then severity or damage on those plants. And then for pitfalls, this is a pitfall right here. Are you familiar with pitfalls? Did them in a class. So pitfall is just a little cup placed in the soil. There's a little 4-inch hole there. It's the paint cups, the ones you use to mix up paint. It's got antifreeze inside of it. So as the insects are running across the soil surface, they fall into that cup, get stuck in the antifreeze. They don't consume one another. We can dig them out and go through them. And this is a very labor-intensive job to do this. 2 of my other students are working on this, doing pitfalls. One collected over 30,000 insects in 1 season. And that's just the larger ones, not the colembala and other things that are in there, little tiny springtails and other things. And so it takes a long time to sort through those samples. There's a lot of data that comes out. So they're still working on it, but I will mention their studies. But you know, it's basically to capture the beneficial insects that are out there, 1 or 2 pests that'll show up in that type of system. So this is across all sites. I just combined them all for a general picture. But you can see here we've got ground beetles, row beetles, click beetles. Click beetles are a pest. That's the wireworm. Sap beetles, big-eyed bugs, beneficial. This one feeds on fungi. We've got spiders, millipedes, and centipedes. And so we've got a whole range of things in the system. Lots of them are beneficials. We've got all of our different treatments here, and you see wide variations in treatment response between a given location. Some are up relative to the no-cover treatment. Others are, you know, flatlined or even potentially down in some cases. But there's an obvious you know, indication here, especially for spiders, which are relatively mobile and can move around fairly quickly, feed on a lot of different things. They're up in the cover crop system, so there's a habitat there. We used a DVAC. It's like a reverse leaf blower. I'm not going to show that data. We're still actually sorting through it. The DVAC, basically you just take it back and forth across the ground, and you pick up all kinds of little things. We picked up a lot of aphids. So they're probably feeding on aphids in the system, which are not a major threat to any of our coming crops. It's not soybean aphids. It's other species of aphids, but that's likely what's sustaining these predators in this time of the season. So they're there, and they're hanging out in these fields, and as pests show up potentially in the system, these are pretty large. This is a wolf spider. They're pretty large predators that can show up. So we got 4 sites here: Kennesaw, Albion, Cedar Bluffs, and Hardington. Wide variations in the biomass between these sites. Cedar Bluffs was the lowest. We ran a correlation, so it's how much does insect activity increase with biomass increase? There's a very strong relationship. So that's what we would expect. The more biomass you accumulate, the more insects are going to be potentially in that system. And so it was nice to see that in terms of data from a given site, but we haven't broke that up by species or anything yet. This is what I really want you to take away. So when we see an average, we think that's the response on my farm. That'll be the response I expect. That is not the case. Kennesaw here had very large amounts of biomass when it was terminated. You can see there's a bump up in insects in certain cases here for a given set. Albion also had very large amounts of biomass, but Cedar Bluffs was all down. It was all under 20 total. But you can see that spiders in the case of Albion were way up in terms of numbers. Just look at the y-axis here, 140 So we're looking at very different amounts of insects. And this is, I put that pitfall out, we left it for 5 days. So this is 5 days of exposure and insects falling into that trap for 5 days. It gets a really nice smell. If you want to know, stop by the lab. You don't even have to step in, just walk by the door. You'll get a pretty good idea of what a pitfall smells like. But yeah, important to remember there are large differences between these sites. As we do year after year, we'll start to look back in the cropping history, the number of years in a cover crop system, what's in those systems in terms of landscape, and what might be influencing some of these differential responses between sites. I'm not going to show the pest pressure because it was less than 5% defoliation, and we're at 30% in vegetative stages. So basically a flat line of pest pressure. We saw a few alfalfa caterpillar and other things, but nothing that was linked to any particular treatment. It was all very, very quiet year for those. So we're going to make the transition. That's the beneficial insect. We have a lot more beneficial insect work going on right now in these systems. And our lab's general focus is to say, let's look at the system. We're not going to focus on the pest side or the beneficial side. We're going to capture the system in terms of all arthropod activity, and that way we give you a more complete picture. But as we look at the source of risk for pests, you know, the host range spanning both the cover crop and cash crop, anytime that the two are closer and closer in relationship, the more likely that the insect will span both of those systems as a pest. Suitable overwintering sites, so maybe this is not even a food source. It's just a suitable habitat for them to overwinter, and Stinkbug's a good example. We'll go through it. And then termination of these cover crops can drive the insect into the cash crop. Pest or beneficial, there's no food source left. They may move and try and feed on the cash crop even though it's not their preferred host, just because it's the only food source around. Wheat stem maggot was a good example of that in 2017. So black cutworm, anybody had issues with black cutworm in the past? This one's highly variable year to year, right? It shows up some years, it's in higher numbers, we have to be concerned about it. Other years it's quite low. The university here, several of the entomologists as well as extension educators monitor for black cutworm in the state each spring. And it's really attracted to dense vegetation in the spring. They come up, they lay eggs, they develop, they grow through several different instars. The adults are not so important to identify because we have these pheromone traps that we use. There's a degree day for these, but it's based on the significant moth capture. So once we capture enough moths, 8 or more over 2 nights, that starts this clock ticking right here. And that's important to you because once we reach this number, 91 through 311, they'll start feeding on the leaves. And so that's the first time we get an indication that black cutworm is in the field, and we might have to do something about it based on that leaf feeding. And so this gives you the early warning system. Typically, we're using BTs in the field. It's not too much of a problem. But as black cutworm gets larger and larger and gets closer to completing its life cycle, it can actually chew through plants that have BT in them and cause some problems because they can handle so much. And so because you have a BT out there potentially on your corn, don't think you're in the clear. They'll also do soybeans. Soybeans are just so forgiving in terms of the population. Often we don't have problems in soybeans, but it's worth scouting both of them. So here's that initial leaf damage that you might see. These guys hide during the day, so they can be tough to find, but I would look for the leaf feeding as the initial signs, or plants being cut off right at ground level or slightly below, wilted plants in the field. We're looking for about 3 to 5% damage and 2 or more present in a given set of plants to initiate anything being done about them. So for those of you that were in the talk yesterday, quiet, don't say anything. Okay, which one? So we have a number of instars here that they go through, so many days of development that it takes to go through that process. They cut so many plants based on the development stage of the plants, but this also varies by temperature, and this complicates the situation because we may see them one year and say, oh, I had them, but I didn't have any problems. Or in other years, we may have significant problems. So of these 2 scenarios, which one would you be more worried about? Who's worried about the 60-degree cooler temperatures as a greater impact from black cutworm if we stay cool? Who's more worried? A couple of you? Okay. Yeah, you're right, because up to 12 plants can be cut if it stays cool. And essentially, these insects develop at a lower temperature than what the crop develops at. So they can feed on more of the plant because it's growing less and there's less biomass out there. Then when it's at 80 degrees, the plants pick up in their development, they grow relatively fast, there's more tissue for them to consume on a single plant, slows down the number of plants that they can cut. So just, if you're seeing us come out with a report that we're seeing a lot of black cutworm, look at the next 10 days, check your crop. If you're at 60 degrees or looking at 60, that's, if you got some out there, just remember they can be cutting a lot more than what you might expect. This photo Nathan Mueller gave me from about 2 years ago. This is black cutworm in a field. This is not a cover crop system. This is just a weedy portion of the field. They did have some oats out there, I think he told me. But essentially, they'd sprayed this out in the spring. Oats were obviously already dead. But the black cutworm had come in because of the dense vegetation and caused some problems in their corn because there was some vegetation for them to start on. And so just one thing to keep an eye on. True armyworm's a lot like black cutworm. It comes to the system. It just feeds a little bit differently. And of course, the adults look much different. They lay their eggs on spring vegetation, and they deposit them on the lower leaves and develop on the cover crop. Once the cover crop's terminated, that's when they move relatively rapidly to corn. And the symptoms are a little bit different here. So remember, we were talking about black cutworm. There were these spots in the leaves, and then they go directly down on the stem and cut off the stem. True armyworm feeds up on the leaves, tends to feed from the outside of the leaf in, and so they kind of have these notches in the leaf. So this is one you might run into. Same time, you're also looking for black cutworm. They feed at night for about 3 weeks. It's the same for black cutworm. A lot of these insects, as they get to their later stages of development, a lot of the feeding occurs in those last few instars. And that's like a double-edged sword because that's really when you start to notice them. But then it's really difficult to control them when they're large. So, if you're difficult control once you get greater than an inch, but 25% or more damaged plants, that's when you might want to do something like that. A lot of predators, parasitoids, fungi, and viruses. I'm hitting these key insects because I'm actually going to hit a study with cover crops that focuses on these, and they were monitoring for them in the system. Last one's common stalk borer. I bring up common stalk borer because it's the flip of the system. Everything's been coming in the spring so far, right? We've been talking about spring infesting insects. This one comes in the fall. The adults are out from about mid-September through mid-October, and they're targeting any dense vegetation that's around. They like grass blades that are actually dead, so that might keep them out of our cover crop systems a little bit, or ragweed, but they're essentially looking for a place to lay their eggs. They overwinter as eggs. They emerge in the spring, and they have this, from January, degree day calculation that we have that'll bring you out to the time of scouting. And I've got calls on this in cover crop systems before and came out to it. Very low levels of damage dispersed throughout the field. And so it's not something that's a major concern. I did have some larger calls, but couldn't actually communicate with the individuals to find out if that was the case. These cause dead heart symptoms. Dead heart symptoms are usually after V3. Prior to V3, they can outright kill the corn plants because they get so quickly to the growing point to feed on these. But dead heart symptoms till about V8, and then once you get to V8, they'll cause some leaf damage, but you're pretty much out of the scenario of significant pressure. And so they vary a little bit by stage of development. So this is a degree day base 41 Fahrenheit. It starts on January 1st and moves through. At about 1,300 or so degree days, you can start scouting. This is the thresholds at the different V stages, so you can see that the percent infestation increases with stage of development. So this is one that early season, as you're in those initial stages of development, is good to scout for. Okay, Dunbar has a study that focused on those three insects, specifically in the system, on-farm study, full-scale strips in the field that they were using, and essentially it was a soybean system planted to a rye cover crop that was planted right after the soybeans in September. They terminated about 14 to 21 days before planting. I think a lot of entomologists, when we first looked at this system, were not as focused on the time of death of the cover crop. We're certainly a lot more focused now. So when is it actually dead? Because I know many of you have experienced this. If you spray in early April, it may take 20 days for that cover crop to die. But you spray May 1 or May 5 and it's warm, man, that thing will smoke out, 3 days. It's crazy how fast it'll dry down and die. And so this is becoming not necessarily the day of the spray, but the day of death. And so we're working with a remote sensing specialist, Yin, to see if we can develop some remote sensing techniques for determining time of death. We're also doing that in the greenhouse on wheat stem maggot to say, okay, after we spray, when it's dead, when will they move? And so there are a couple other things. But these guys sampled weekly all the way through V8. They also put out these pheromone traps to track. So here's one of the pheromone traps, the adult pheromone traps for true armyworm. I've highlighted 2 green lines here. This is from the same year, 2014, really no difference. They're almost the exact same all the way through. Just year-to-year variability again. It's the way these systems work. But you can see in the rye cover crop for true armyworm, with the rye being present, we're seeing more in the initial part of the season here on the rye. So this is something that's driven into the rye portion of these systems to potentially lay eggs on. They're just looking for dense vegetation, if you remember back to when I was talking about their ecology. Next one here is black cutworm. Again, elevated in one year, not in the other years. They're almost the same. And so this is potentially coming up to what could be a problematic situation for this cover crop system. And so if we look at the actual data, so the number of larvae that are present in a given area, we've got the cover crop system in 2014 here. We've got 19 over 1. We didn't see a significant difference in the adult movement for that year, but for the one that we did, it was 77 over 5. So that's a lot more true armyworm present in a cover crop system than the no cover crop treatment. Again, if that was the situation you ran into, it's not the end of cover crops. These are easily manageable systems. If you find them early enough, you can get out and take care of the situation. Black cutworm, although we saw the adults, didn't translate to a successful black cutworm population, at least from their interpretation, in the system. And so again, you know, what is there beneficial insects in the system that may have been active that reduced them from completing themselves to actually causing any potential damage in the field? And then common stalk borer here. Common stalk borer flips between the two seasons. Cover crop was higher here, and then it was lower and more in the no cover. So it's a toss-up. Year to year, it varies. The end goal from all of this, you take anything away, scout your cover crops when you're planting, especially in the early development stages, you know, to make sure you're not causing any risk. This usually gets people's attention. This is Adam Varenhorst from South Dakota. You'll notice there's no corn present here where the cover crop is. This is simply where they left it, let it go. There's a high population that was present there. Adam was originally at Iowa State with Dunbar, and you know, you can see those problems if you're not you know, watching out for them. I don't know why that comes back again. Questions so far? Comments on any of these? Okay, so stink bugs. Stink bugs, obviously a big switch from all of the moths that we've been focusing on so far. Stink bugs overwinter as adults. They're attracted to wooded areas, grass borders, cover crops, and they've been increasing in their abundance and activity in the Midwest. And there are a number of students. There's one here at the University of Nebraska, Blessing, that's focused on describing all the species in Nebraska, a lot more than we thought actually through her initial phases of research. And so this is one to watch out, especially on corn, because unlike soybeans, corn, they're a pest the entire season. So soybeans are a pest in the reproductive stage, and the disconnect between the cover crop and the reproductive stages in corn, I think, alleviates a lot of pressure for us. But for corn, because they can span the entire season, we've got to pay a lot more attention coming out of those systems. And we have had reports in the past. Tom Hunt, Bob Wright have done a lot with that. Not necessarily in cover crops, but with stink bugs. Few reports in cover crops. So fields with increased risk, the no-till cover crop prior to planting, corn following wheat. You know, significantly higher stink bugs in cover crops. This was actually done on cotton. Did not impact cotton yields. And so this is just one to be looking for while you're out there. I bring this photo up because, you know, just by their very name, stink bugs don't get a very good, you know, PR because everybody perceives them as a pest. But in fact, the two insects on the bottom here, one is a beneficial insect that's a stink bug, the other is a pest. This is the brown stink bug, and the other one here is the spiny soldier stink bug. So not every stink bug you see in your field is a pest. So in particular, really important in soybeans. I see these every single year. They are voracious predators in the field, especially when it comes to the leps. But you know, it is difficult to tell them apart. If you really got a question, turn them over, snap a photo, send it to me. I can probably tell the difference if you got a nice clear photo. Antennas are a little different between the two. And then their mouth parts here, you can see the channel is divided in this one and quite a bit larger than it is in the brown stink bug. There are some other subtle characteristics that exist on their bodies. They're not always definite, but just reminding you that not every one of those that you're looking at is a potential problem. Jim McGill took this video and sent it to me. I thought it was pretty neat. Who likes Japanese beetle? No one. Not even entomologists like them. They annoy me in the field. But these things attempt to feed on Japanese beetle. I think that's a pretty hefty toll to take on a Japanese beetle relative to the size, but they are out there feeding on things that are a problem for us in these systems. Okay, so as I mentioned, they're a problem throughout the year on corn, and so they go through their development cycle here and potentially cause some issues. The first one is the early season issues that can kill small plants. This photo is quite small here, but what it is to show you and remind me this is an open furrow. So if you're having issues getting row closure in your corn, you're leaving an opportunity for a stink bug to get down, contact that growing point, and they'll inject an enzyme as they feed, and that could really mess up the development of plants. So make sure you're getting good row closure to avoid issues like that. Here's another one trying to get down to the base. What they do is they cause a lot of dysfunction in the plants. The plants tiller rapidly. Tillers are really bad in corn. If you've ever seen those tassel ears where the ear sticks out of the end of the plant and it usually sticks out to the sides, sometimes you'll see it on the whole plant, which means it's really received some damage. That's never a good scenario for a yield outcome. The other one is this repeated shot hole pattern. Basically, they shove their stylet all the way through the stem, and as they do, they contact the rolled up leaf inside, and so they create this whole pattern. The only other thing that I've really seen do that is hail damage. If you get hail contacting the leaf and causing multiple damage points, you'll see that same pattern, but you'll know if you got hail. And so that's one to look for early season. Thresholds for this, they've been working on thresholds for a number of years. 5% damage, brown stink bug present, and then greater than 10% infested when the corn is less than 2 feet tall. And so these are some rough estimations. There used to be a lot of them for different states. I think all the states are trying to get on the same page in terms of a threshold for stink bugs. Late season aborted kernels and banana ears, these are certainly more risky when it comes to potential yield loss. That plant's been there, it's been utilizing nutrients and competing with the other plants, so this is the worst time that you can really lose these for a lot of yield. But those aborted kernels and banana ears, again, it's due to the enzymes they inject in the plant. This is a lot of what I see every year is these little stippling, if you peel back an ear of corn, you see these little brown spots on there that often have a little white center in them. That's typically brown stink bug feeding in the ear. So there are thresholds for these as well. 1 stink bug for every 2 plants from ear forming through pollen shed. Once you get past pollen shed, the risk goes up quite a bit. Doubles 1 per every 4 plants, pollen shed through blister. So that's one to look for in these types of systems. For soybeans, we just really move right to the reproductive stages. So we're not as concerned about the early stages here. Seed and pod damage. This is just a range of symptoms going from very healthy all the way through to very damaged. Saw a lot of stink bugs this year. Actually, there's a few people on Twitter that said that their hopper in the back of their combine had a whole bunch of stink bugs in it. And I think it was some of our later maturity groups drove some of those in. Had a maturity group study going at Mead, and there was a lot of stink bugs showing up in that system. Blessing was having a heyday collecting stink bugs. Delayed maturity, a stay green syndrome. 5% of plants exhibiting any sort of symptoms, and 10 to 25%, or 10 stink bugs for every 25 sweeps. Sweep net's a great way to collect a lot of insects and soybeans. Give you an idea what's going on. One of the last ones I'll talk about is seed corn maggot. Anybody ever had seed corn maggot issues from cover crops? Yeah, it happens every once in a while. We had one down near Clay Center that had issues on soybeans this past year. These are situations where everything kind of just compounds itself. Proximity to a feedlot where a lot of the adults are present, cold temperatures, applying manure and working it in prior to planting, especially while the adults are active. You see a lot of unemerged plants. This is where you got to do a bit of digging. And weak seedlings are a good indication that you may have some of these present. But even for the field that experienced them, there was no significant yield losses. Soybeans, again, are very forgiving. And, sometimes they're just feeding inside the cotyledon here. And so you can take a beating on the cotyledons and still have a pretty decent yield in soybeans. This is a study that addressed that, 1989. They used tillage. Tillage is kind of the key, working up the soil. That CO2 that's being given off is attractive for them. And so you can see the conventional tillage here with the seed corn maggots, the units of soil here, you can see more activity. So no-till systems tend to avoid a lot of this. And then the other one here is southern corn rootworm that was in this study. And you can see there was significant pressure here, no-till scenarios with the cover crops, crimson clover and hairy vetch. They had a bump up in damage for both of those. And so one more in the system. Bean leaf beetle. This is one that you may find, again, you'd have to plant pretty early. I think it runs counterintuitive to when we plant cover crops, which is usually a little bit later. These things are really mobile. They move around pretty quick. A wireworm is one really difficult pest to work on. Highly variable year to year. They can range from 4 to 7 years in the soil. Usually if we're trying to understand this thing, we're putting like 40 reps in a field, hoping that some of them will line up on pressure. So if you have pressure one year, that's the take home. If you have pressure one year, doesn't mean you'll have pressure the next. You can put out bait traps. If you want to do this, I'll tell you, I'm probably not going to join you. It's kind of annoying putting these out, but there is ways to sample for them. Okay, so I'm going to spend the last few minutes. Am I doing okay on time, Tyler? Great, okay. Anybody have any questions so far? We're going to focus on weed stem maggot for really the remainder, and then a few studies that we're doing. So this is a new pest to cover crops. Showed up one year and then it just disappeared. And I think, you know, if I can write this into my activity insights, usually if I focus in on something, it's gone. So you're welcome. It's really hard to do research when everything disappears. It's a major pest one year and gone the next. Let's hope it stays away. We're going to continue studying it anyway. But everybody remember spring of 2017, cold, wet spring. It was a real challenge terminating cover crops for a lot of growers, I think, that season. And what we had was our high temperatures kept dipping down into some very low, I got this in Celsius, but what is it, 10 is 50, 22 or so is getting into the 70s. So, you know, we had some cooler temperatures, and to compound that, we had rain. And so field activities were limited when we could get out there and terminate. This is the optimum range for glyphosate. So we were dipping in and out of that optimum range. And what this highlighted was I was visiting fields where growers had 2 to 3 applications trying to control or remove their cover crop so they could plant a cash crop. Essentially, they ran later and later in the spring. So I got to plant my next cash crop. I can't wait any longer. So they planted green as a way to do that. And, you know, I talked to Jenny Reese and a lot of others. Green planting works in a lot of years. This just happened to be a year where it put these people under a significant amount of pressure from a particular pest. So May 23rd, our first report came in. It came in like it was common stalk borer. That's how it came across to me in the email with the initial photos. Was we had these dead heart symptoms in the field, so a dead center on these plants. They were V3, V4 stage. And so that's initially what we thought. It's courtesy that I always get a blurry photo with every one of these. Actually, it's really hard. I was out there trying to take photos with my phone. I got the same thing until I got them in the lab. But that does not look like it has a head capsule. So take away common stalk borer is not common stalk borer. That's a maggot of some kind. And so we were struggling to understand what this potentially was. We dug it back into the field or into into Lincoln, and we reared out the adults essentially to figure out what the adult form was so we could be more confident in the ID. But what we had was this channeling all the way down the plant. This is the damage channel they were creating as they were feeding all the way down until they contacted the growing point, which if you kill a growing point that early in the season or damage it in some way, you get tillers produced on those plants. We certainly saw a lot of those. So this is essentially a graphic showing that tillering all the way down until the growing point. There's a whole stack of nodes down here. They've got ears already ready to go. One of those is the one you're going to harvest at the end of the season. And that's already happening by the V3 stage. So once this tassel's initiated in corn, that essentially the last one to form, that's your big yielder that you're going to be taking off of that field. And so imagine an insect coming down, chomping through that entire thing, kind of wreaks havoc on the hormones of the plant. And it responds by producing a tiller. Essentially, it shoots a tiller out the side. And the unfortunate part is that tiller results in a tassel ear in most cases. And so I was not a happy camper to be around in these fields because I was seeing a lot of dead main stems and tillers and suggesting to growers that this may be the fate of a lot of those plants. Some of them were up to 60% of plants infested within where the cover crop was growing. And so there was a big concern there would be very significant yield losses in these fields. Luckily, it didn't turn out that bad. Still not good, but the potential was there for some significant losses. So last part of this was, you know, that they were typically found within 2 inches of the growing point of the plant. This is just kind of a summary of those symptoms, but they were all the way below ground in some cases. And obviously they were entering through the whorl and burrowing their way down with that channel increasing. So this is where the field reports came from. I could have spent a lot more time through this area. We just simply ran out of time trying to sample. As plants got larger, they got harder and harder to deal with. But we had reports in the past. Once we found out what it was, which was wheat stem maggot, we did have some old existing reports from 2005 and 2015 up in the Northeast, so not in the areas that we were focused on. And what we had for characteristics, this is a 12 fields. You can see they planted rye or wheat in each one of these. We actually got a few of these filled in. I meant to update this. But the plantings here from mid-October, we had one in November. So you can see we had later planted cover crops. And that, to me as an entomologist, says something probably happened in the spring, because that insect was not active in November to infest these. And there would be no difference. We'd be having problems in other fields without cover crops if that was the case. Terminations here occurred over a range of time. Almost all these are a plus. The plus indicates they planted and then terminated afterwards. In some cases, they terminated before, but they were making a second or even third application. So it was the last application made that eventually killed the cover crop that we used for this termination date. You can see symptomatic plants range from almost nothing to all the way up to 60% in some cases. And we had a number of wheat stem maggots that we recovered from these. and we reared out adults, and then the larval size was all over the place, meaning that we were seeing a lot of different stages of development. It wasn't all consistent, meaning they were probably moving over a space of time into this particular system. So this is to highlight kind of how the system worked. The bars represent when things came into the system, or when a practice started and ended. And so you can see many people started early terminating. All of them ended up being green planted. The cover crops, imagine this is back over here, were planted, in that October through November, lots of wheat and rye. If we overlay this, I was really confident standing out there with people because I was looking at a 1937 publication trying to give those people advice on what to do, and there was nothing to do that year in terms of this system. But overlaying these two systems and saying, okay, assuming 1937 holds and the development cycles, the adults could have come in the spring, essentially laid eggs into the cover crop, and then the larvae essentially were present as the cover crop was dying and simply moved. The larvae moved to the next cash crop. And so you can see how tight that window is, right? And so the potential for overlap varies probably quite a bit year to year. We tracked them this year for the adults. We picked them up on April 16th. So dead on the nose from 1937, I think we were a day off. Haven't changed a lot in 80 some years. So it's surprising how consistent they were, but we collected such a low number. We swept for weeks and weeks, and I think we collected like 5 total. And that's not uncommon for an insect to bounce up into these horrendous populations, and then something else takes a hold of it as a niche. It decides, oh, I'm going to feed on the weed stem maggot larvae or adults, and the population declines quite rapidly. Could be fungi, bacteria. For whatever reason, they've declined quite a bit. There's the adults, very easy to identify. And here's all the emergence. So regardless of the fields, the variability that was seen within the field, all the emergence tended to kick off around the same time after we isolated them from the field. We recovered quite a range of larvae or adults depending on which field they were collected from. And in some cases, we actually collected more than one adult from a single plant, which means there was more than one larvae per plant. I should have had Jenny Reese come into town. She was really good at finding doubles. We were not as good. So weed stem maggots likely laid eggs fall or early spring, really hanging on the early spring just due to the timing in some of these. In the larval development stage, they were in the larval stage at the time of the cover crop termination. And this photo highlights it. I don't know if you can see it without the lines, but once you pop the lines, you can see these clearly defined lines. So on this side, cover crop. And on these sides, there was no cover crop present. This was a gully within the field where they'd actually planted cover crop throughout the whole area, trying to reduce erosion as it came into the bottom. And so they had some spaces with and without. And literally, as you come out of the cover crop, even just a few feet, things jump up quite rapidly to normal. And so it told me it was very localized, quick movement that was initiating a lot of this, and that it was likely the larvae that were the source. Some of these growers were actually taking out the entire area that was cover crop planted, planting corn back into it. And they were concerned whether or not the adults would lay back onto the corn if it was the only thing present. We tried desperately in the greenhouse. We collected hundreds and hundreds of adults. We tested 1,200 corn plants where we gave adults access to only corn. They never completed development on corn. It's really good news. If weed stem maggot made a jump to corn and could lay eggs and develop on corn, it would become a very significant pest if it was present. So none of that. And so that was good to see. The yield impacts were not clearly defined. The issue was it was a compounding variable. So that means that we had cover crop present on top of where weed stem maggot was. So you couldn't isolate it from the system. Tillering was the potential to reduce these yields and competition between plants. Of the growers that had yield monitors and pulled in and out of these systems, with the patch plantings that occurred in a field, they said about 30 bushel yield losses. And they actually said that with a degree of happiness, that was all the yield loss they were experiencing. It's still really significant. This is not a joke. But clearly there's an opportunity here to manage this system. We had a grower who tank mixed insecticides and still saw a bit of pressure in the field. And so the question is, if we do run into a scenario where we do have significant weed stem maggot pressure, what do we do, right? So we can avoid the significant risk of something like this. Lots of people ask me about seed treatments. The 2015, they happened to be running clothianidin in a trial with some very high rates. It did nothing in the trial. So seed treatments don't appear to have much of an effect. Tank mixing, the time of death, that's the issue. So we were talking about time of death earlier. The plants take time to die, but you apply the insecticide with the tank mix, and it has so much residual activity. It's going to be present for so long, and then its activity is going to be gone. And the fear is the activity of the insecticide is gone by the time they move, which means you applied it, you maybe knocked out a lot of beneficial insects in your system, but the weed stem maggots could still make the move to corn. That's the fear. And so that's what we're studying in the greenhouse, trying to understand this. But there's unlikely to have enough residual activity, and then that risk of killing those beneficials. We had grazing systems that were involved in this. And even the 1937, there's actually 2 theses that were written in the mid-1900s. No effect on the maggots by cattle grazing in the field. They're too low in those cover crop plants. But terminating about 14 days prior to planting. I know that doesn't agree with some people because it gets away from the maximizing biomass. But this is a non-insecticide mechanism. Make sure the cover crop is dead, essentially, prior to planting. And I would do this, if you think you have significant pressure, we're seeing significant adult flights, you've had a problem in the past, that might be a way to manage that. So the impact of insects in cover crops, or arthropods in cover crop species, I think, plays a big factor. On the wheat stem maggot, we had triticale in some of these systems, didn't ever find issues from a triticale field where they planted triticale as a cover crop. That's really interesting. It's just wheat and rye cross, right? And so we're studying that in the greenhouse. I got a student actually early January here. We finally got the colony up to a mode where we can test triticale. We're going to put a lot of pressure on triticale and see if they can survive on it. Triticale is more expensive to plant, but if you're have cattle, it's got the forage quality that comes with it, so that might be a potential opportunity. Management practices, obviously that termination timing and method. Environmental factors, this is one we just pieced out with a lot of studies. Scouting is really the key to avoid significant loss. You know what's there, you can manage it in advance. And then spraying cover crops with an insecticide, again, those beneficial insects. So these are some ongoing studies we have. Gabby, one of my master's students, is working on a planting date and termination, the combination, planting it 4 times in the fall, terminating it 2 times in the spring. So the combination of those practices with oats and rye. Why oats and rye? Oats builds biomass really rapidly in the fall, and then the rye takes over in the spring. And oats, they've shown down in Kansas, oats by itself, it fall terminates, but they've seen a lot of potential reduction in weed competition with oats, even though it doesn't need to be sprayed out. And so she's working on that. I think she collected about 12,000 arthropods this past year. A little bit of differences between the cover crops. We had kind of poor patchy establishment in some of her treatments. So she's got a really nice study set up this year. That one's picture worthy. We have time-lapse cameras sitting out there. So look for the time lapses on that one this coming spring once we start to terminate. Cover crop species and termination study. This is Julia, another one of my students, working on wheat, rye, and triticale. That triticale is that big question when it comes to wheat stem maggot, but we're studying the whole system in the field. She's also doing some greenhouse work, looking at termination, time of death, and movement of wheat stem maggot, and then 4 termination dates in the spring, going from 20 days in advance of planting to 10 days to 0 to +5. And we're monitoring the time of death of each one of those so we know roughly when they're dead. You think time of death would be an easy thing. It's actually quite hard to tell when plants are dead in the field. So cover crops and insect use study. Gabby, this is a SARE-funded project. They just funded this. We're starting it this spring. So what we'll do is we'll actually tank mix and delay insecticide applications. So we're going to apply one with the herbicide when we terminate. This is done on 2 grower fields up in Lancaster or in Saunders County, as well as on the station. And then we're going to delay 10 days and apply an insecticide after 10 days. So the question is, if wheat stem maggot's present, what does it do to wheat stem maggot? We'll be really lucky if that happens. The bigger question I have is the beneficial insects. Been toting it through this presentation. Every talk I give, we're going to show you the impacts of applying an insecticide without considering whether or not a pest is present and the potential impacts on beneficial insects. That's what I got. I probably went over. Go over? It's a little bit. Okay. I'll take any questions if you got them. Yeah.
You mentioned about oats and rye, and oats dies out in the winter.
Yep.
And rye greens up in the spring. Does that have a beneficial impact on the pests then? Those, or there's no green matter for them to live on in the spring? So
question is, the oats and rye combination that we were using in the study, or just oats by itself, does the oats dying in the fall generate any potential issues in the spring for pests in the system? Potentially. Decaying material in a system, just like when we're applying the manure to a system, that seed corn maggot, it'll be attracted to that decaying material. So if you work those oats up as they were dead in the spring prior to planting, you could draw seed corn maggot in. It varies a lot year to year, depending on when you planted, relative to their flights. But that would be one I could foresee potentially coming into that type of system. Not a guarantee, but good question. Yeah.
Looking at the insects, turnips and radishes, a lot of those corn production.
Yeah.
There's tremendous problems with corn maggot, smaller vegetable,
Yes.
literally destroyed soybean.
Yeah, I'm not currently doing anything but with that, but I know I was at a, oh yeah, so seed corn maggot and another type of vegetable seed maggot of some kind, in a radish system that was going to seed corn and having the carryover of those being a problem for the seed corn. Is that right? Oh, soybeans.
Male rows out of our seed corn at that time. We put turnips, radish, and millet.
Okay.
Spread them at that time. All crazy kind of stuff.
Mm-hmm.
But the seed corn maggots come in that, and the vegetable seed maggots
Mhm.
come in. And when you put
Soybeans,
in
okay.
the spring, in a cool, wet spring,
Yeah.
destroy it.
Okay, so putting that in after you do your male row destroyers, you're putting on your radishes, and then in the spring when you plant soybeans, you've had an issue with seed corn maggot and this vegetable seed maggot as well. I've heard that. It was almost over a year ago, in fact, that I had, well, less than a year ago, that I had a conversation at a seed corn growers meeting about that. Don't have any funding to do that. I'm not currently working on that. It's definitely one that's out there as a potential to look at. I think, if you're looking at seed corn maggot, those flights are really critical. And if, since I'm not working on it, but if I can provide you some advice, it's look at the flights. If you're not sure, go ahead and give me a call or Bob. Bob usually posts every year when the flights are occurring. And there's that critical window when they're attracted and going to move onto decaying material. And then the tillage. Tillage is a big component when you're looking at them potentially coming into those systems, because it's that disruption that'll bring them in. Seed treatments do a pretty good job of controlling them, but it depends on what you can do in the system. Yeah.
Not for seed corn, but some of us are flying on turnips,
Yep.
radishes, and rye. Same thing. So other states are not doing any studies on this. What can we do to
Sure.
get some funding? That's probably our number one problem.
Yeah. Well, I've tried to do the boards a couple times, but it is difficult. There are a lot of questions out there, and so it depends when it rises to a level that is needed. I work with seed corn maggot doing insecticide studies every year, and the insecticides work pretty well. So the trick is knowing whether or not you're under risk. Are you creating a high risk environment? Well, evidently, but are you tilling these areas? No. That's quite surprising and a new one for me. Typically, that's what really drives them into these systems. But monitor. So maybe you guys work with me this spring as we move into the spring for the adult movement, and we'll see if we can work that around the system. I know it requires a bit of flexibility to when you plant, which is never the easiest scenario. I know what I'm asking. But getting outside of that window for disruption, because it may be actually your planting disruption that drove them in potentially as a start for an issue. And so although I'm not working on it, I can provide a bit of advice in the spring as you move in for pressure to give you some potential options. So yeah, it's surprising how well the insecticide trials have worked when I've done this in the past. So Tom Hunt's another one that does a lot with seed corn maggot. Other questions? Wish I could answer all the questions in 1 year. I know somebody mentioned in the back earlier about soybean gall midge and said, is it connected to cover crops in any way? This is one that's kind of rocked the system this year. We're working on it, doing a lot of work with it. We've had a rare case where they've had a cover crop in the system, and it's been in the cover crop, not in the cover crop, but in that type of cropping system scenario. But this was a 4-state issue. I'm happy to talk to anybody afterwards about it. But it doesn't appear to be linked to cover crops. There's not a strong relationship to cover crops. That's another one this spring we'll be doing a lot of monitoring on. But no link to the cover crops as far as we know yet. So good, Tyler. Thank you.